Thank you for coming along tonight, and thank you for people joining us online as well. And we'll see if this keeps flashing as we go through. I was going to say I apologise. That's probably not entirely correct. I normally come to do these talks, and I come very professional, and as a proper consultant should. But I've been doing a couple of talks around chaos engineering, and this little guy kept popping up in my recommended products. Now they keep telling us that the devices don't listen to us. I'll believe them, but he seemed appropriate, so somebody's algorithm somewhere is working. We'll give them the benefit of that. So, as I say, thank you for coming along tonight. And we're going to start with a little audience participation. Now, this will either go really well or really badly. So far, when I've done this talk, it's gone okay. So, how many of you are involved in writing code? So, either yourselves or in a team. Okay, good, excellent. That's nearly everybody. It's a good start. Hopefully it carries on. And how many of you are involved in writing tests for that code? Good. And running the testing pipelines, it's the big thing these days, DevOps, automated testing. Excellent, thank you. Now, the reason I was asking those questions is I'm obviously going to be talking about chaos engineering and testing tonight. And I think for most of us, it's probably a bit of a surprise when we come into it. We all think about writing code and creating new applications. But we don't necessarily think that when we come into the industry that testing is going to be as important as it is. Now, love testing is possibly a slightly strong word for it. I think we all recognize how important it is though. And as a community builder, definitely for me, I'm building a lot of things. I do a lot of testing, trying things out, making sure it works. But I really do think that inventing things and building things is part of our personalities, human psyche. And it has been there for a long time. I mean, if we think back, the first guys rubbing a couple of sticks together, trying to get a fire working, they'll have tried different wood, tried different speeds, techniques, and eventually they'll have got to what they were looking for. And we've got this guy here. Now, he's definitely going to need a few more testing iterations, but it's going to get there eventually. And as I say, for me, testing is a really important part of the work that we do. Now, before I go on to talk more about testing and on to chaos engineering, a little bit of a quick introduction about myself. So, as it says, Simon Hanmer. The QR code is my LinkedIn profile. Feel free to scan or not. I am, when the screen comes back in a moment, I don't know if this is my dongle. If it is, I apologize. Okay. I'm a member of the AWS Community Builder program, and that is a program that AWS sponsors for people who are interested in sharing their learnings, their experience, what they're doing with AWS. And that's kind of what got me into this. As I say, I like building things. Like a lot of us, I like trying things out, seeing what works, what doesn't. If there are any questions around the Community Builders programs or the other community, feel free to come and grab me afterwards and have a chat. But in my day job, as you mentioned, I work for a company called GlobalLogic. We're part of Hitachi. Hitachi you may have heard of. GlobalLogic probably not so much because of the work that we do. I am a principal consultant, and as part of that work, I mentioned to a few of you, I tend to work with enterprise services. So we're doing a lot of work migrating workloads into the cloud, be that servers, serverless work, all of that kind of stuff. And I work with infrastructure a lot. I'm not a developer per se, but even as an infrastructure person, we will do a lot of work around testing. And definitely a lot of the work that we do with our clients is helping them automate how they deploy the applications. It's an important part of anything we do in cloud these days, is how can we accelerate, how quickly we get the code out there, automated testing I mentioned, pipelines, all of that kind of stuff. And it was that work that I was doing with one of our clients that got me interested in what I'm going to be talking about today. So, we've mentioned testing and automated testing. We've got a lot of different ways of approaching this. We've got unit tests. We break our code down into small functions. We test those as we go. It gives a lot of confidence in that the individual pieces of the code work as we're going to expect them to. We'll do functional testing. Do our applications work end to end? Do all of the pieces come together and work as we expect them to? Integration testing, we might be working with APIs, other systems might be taking the output from our programs, all of this kind of stuff. We need to know that, especially if we're making changes to our code, that it will continue to work with these other systems. And besides all those tests, we're actually, a lot of people nowadays will use testing to drive how we write the code. We will do test-driven development, behavioral development, where we write the tests before we even start to put code together. But I would argue that with all of these testing, they're all thinking about one thing. They're basically thinking about our code. And there's a piece of the picture missing when we look at this. And that is, how can we test what our code is running on? So not just the code, but the servers, the serverless environments, and we've got databases, even the networks that underlie all of the work that we do. How can we test that? Well, it's probably no surprise that I'm going to say it's chaos engineering. So, I don't know how many of you have come across chaos engineering before. I'll give a brief description of it, and I'll give a little bit of the history as well, so we can see how we've got to where we are today and the rest of the talk that I'll be giving. So, chaos engineering, first of all, this quote is from Netflix. So I don't know if anybody's looked at chaos engineering. If you have, you've probably seen this. What it's basically saying, chaos engineering is looking at how we can test our environments in what you might call a chaotic environment, so things going wrong, slowing things down, servers falling over. How can we introduce turbulence into our systems to test it and see how well it works, and get the confidence, if it will work in the worst case, hopefully in the best of cases, we know we're going to be okay. And if we do hit those worst cases, we've already tested for them. So I'll come back to Netflix shortly. And Netflix is probably the thing that people think about if you've looked at chaos engineering. But it actually started quite a while before that. So a little bit of a timeline. And probably the earliest actual kind of implementation of chaos engineering I can find is this chap. So he worked at Apple when they were starting to introduce the first of the Macintoshes. So things like the Lisa, the Apple II, very early iterations of the hardware. And unfortunately, I remember some of these. At this stage, servers and PCs didn't have a lot of memory, they didn't have a lot of disk, they didn't have a lot of resources. And as people were using them, they'd often find that applications would just crash because you'd have memory leaks, all of these kind of things. So Steve Capps was writing the early versions of Mac OS. He was doing things like, he was involved in writing Finder, all of those utilities that sit underneath everything that we do. And as I say, he wanted to way to test the applications, to put them under load, to work with them and introduce a heavy usage. And he wanted to do that in an automated way, because if you can use automation, as we know, that brings us confidence. It's repeatable as well. If you can automate it, you can repeat it. And what he found was a way to use hooks in the operating system to simulate system events. Things like somebody typing on a keyboard or moving the mouse, opening and closing a window. And he found a way to automate that, and he wrote a program called Monkey. Now, for some reason, I don't know why, monkeys come up a lot in chaos engineering, as you will see as we go through. So as I say, this is more about applications on a single server, so not the distributed systems that we tend to think about with chaos engineering. But I think you can see it's kind of got the seeds of what we're talking about. Next one is this guy when he comes up in a moment. So Jesse Robbins, he was working in tech kind of in the dot-com boom, late 90s. And he'd spent a lot of time in tech, and he got fed up with it. He wanted to do something else. So he actually went away, and he went to work with the Seattle Fire Service. And he was really impressed with how they trained the new recruits coming into it and how they maintained that training. So obviously they started off with the basics. This is how all of the equipment works. This is how you put it together. This is how you use the safety equipment, all of this. But what they started to do once they'd got that is they would start to do very similar things to what we're talking about. They'd introduce problems. So you're going into a fire in a building and the power all goes out. So you've got to be able to react to that. Maybe the water pressure starts to drop, or you lose radio comms, all of these kinds of things. So the fire service were training them for worst case scenarios. Again, it's that thing about giving people the confidence that they know that if things go wrong, they can deal with it. And he did this for quite a few years. I think he did sort of like 6 or 7 years. And he eventually decided he wanted to come back into tech. And he joined Amazon, hence why we got that in the headline there. He got a wonderful job title. Now, this probably feels like many of our job titles on a day-to-day basis. I definitely wish it was mine more permanently. But yeah, master of disaster. And he was brought into Amazon as they were kicking off the retail side of things with that same idea. How can we test our systems? How can we put together procedures, processes that will let us test for when things go wrong? And he bought that training, that approach that he'd seen in the fire service and brought it into Amazon. And he set up these things called game days. And the idea was you'd have a number of teams, you'd have your normal operations teams running the services, and then you'd have people behind the scenes breaking things. So it might be slowing down a database, introducing latency into it, turning a server off, overloading a load balancer, all of those kind of things. And what they were looking to do is, one, it was testing the systems on a technical level, but they were also looking to test their processes and their people. It was, have we got the right monitoring in place? Do we know what to do when things go wrong? Do our processes describe how we should deal with incidents? As I say, the next step in the timeline is Netflix, and this is the one that people tend to hear about. And the reason for that is, in 2011, they published a blog post, and they were starting to talk about the approach that they had. And this was, strangely enough, I don't know how many of you remember Netflix at this stage, it wasn't a streaming service, it was posting out DVDs. You'd go onto the website, you'd choose what movies you wanted to watch, they'd stick them in the post. It was straightforward e-commerce, really. And their servers had gone down, so they wanted an approach that they could bring to their engineering teams, similar to what we've been talking about. Now, Netflix will share, they're very good at sharing the technical details of what they do. And as I say, they'd written this blog post about a simian army. Now, what we mean by the simian army is something like this. Imagine a horde of apes get loose in your data center, okay? First, you're probably going to sack your physical security people, because why are they in there? But once they're in, they're going to run around, they'll pull out disks, they'll pull out power cables, they'll push buttons on the front because they've got pretty flashing lights, all of this kind of stuff. They're going to be in there and they're going to be causing chaos, hence the name. So as I say, they published this blog post and they started talking about some of the tools that they used. And they started with a single tool called Chaos Monkey. How many of you have heard of this before? Anybody? Okay, a couple of people. Very simple idea is it would basically go around and turn servers off at random. And the engineers knew that this tool was going to be running, so they started to think about their infrastructure architecture, but also the software architecture, how we deal with failures, how we build resilience into the software. So things like, if something isn't there, we'll come back in a little while and we'll try again. Can we do graceful degradation? If we're doing a game, for example, many of you told me there's gaming here, does it matter if we can't show the high score table for 10 minutes, as long as people can play the game? What's the priority in the services? So this is what they started talking about. They introduced other tools as they went along. So they moved to AWS and they introduced a tool called Chaos Gorilla, and it simulated turning off availability zones in AWS. So hopefully most of you are familiar with availability zones. If not, think about them as the data centers where our services run. They should be separated, so if we lose one, the services can carry on running somewhere else. And Netflix started using these tools, but they got to the stage, they didn't just use them in their test environments, they ran them all of the time, even in production. And the idea with this was the engineers know that there's a good chance that their servers or their applications are going to go wrong at some point. So as I say, they thought about that resilience, they started to build that in. And Netflix open sourced most of these tools. So you could go out, and I know enterprises that have done this, they've taken the Netflix tool sets and they've taken them into their data centers and they've had teams who will set it up and they'll run it. But that means you've got to have resources that understand that. And that's probably not your business. Your business is doing gaming. My business is, say, financial services. So you have to have teams that understand how this approach works. And that's an overhead. It's not your area of expertise. And that brings us on to the next step in the timeline. Amazon. Amazon do this wonderful thing called undifferentiated heavy lifting. And what they're looking to do is, if they see a lot of their customers doing the same thing, and they can take that and make it easier, they will do that. They will do the heavy work. A good example of this they did was when they introduced AWS Backup. So up until that point, people had kind of had to spin their own solutions for backing up services and data. And that's kind of an oversight, really, because everybody's doing that. And it's a service that AWS can sell and they make money on it. So why wouldn't you? And they did the same thing with chaos engineering. They saw a lot of people were getting interested in it and starting to approach it. So in 2021, they announced something called the Fault Injection Simulator, or FIS. And it came into general availability. It means everybody could use it. It was a service that anybody could pick up and use. And as I say, the idea with this was really to be able to do chaos engineering as a service. They knew that people wanted to do this, but why should people have teams that have to maintain the hardware to run these tests or to understand how the underlying tools work? They just want to be able to run these tests. Shortly afterwards, they renamed it to the Fault Injection Service, because that's what it is, it's a service, and it kind of matches up better with the naming conventions that Amazon use. And from there, since 2021, really, FIS has continued to evolve. So they've brought more functionality in. Definitely when it started, it was quite heavily biased towards EC2s. So you could stop and terminate servers, you could introduce I/O latency, all of those kind of things. But as people started to get interested in it, they started to increase the number of services that they could use and test against. And last year, at reInvent, the big conference that they hold every November, they introduced some new functionality. Now, they introduced functionality that would let us test our lambdas, our serverless code, and that's what I'm going to be talking about in a little bit more detail. But they also introduced some other pieces of functionality. So I'm going to go and do you a demo around Lambda. I'm going to talk about some of the other functionality. But before we get into that, let's look at how FIS works. How do we set up these tests? So it's all based around the idea of experiment templates. So this, we talked about chaos engineering as service. I guess this is chaos engineering as code. We want to put everything that we do into code. So it's stored in repositories, it's under version control. And more importantly, we can do things like pull requests. We can do code reviews on it, make sure that people are happy with what we're doing. So they introduced this idea of experiment templates. And these templates are made up of a number of components. So first of all, we've got the targets. Targets are the things that we want to test. EC2 servers, Lambdas, databases. We can test RDS and DynamoDB. We can test networks. We can introduce packet loss, latency, all of these kind of things. As I said, similar to Chaos Gorilla, we can do testing where we can lose an availability zone. Now, the way they actually do that is by introducing changes into what we might call the firewalls, NACLs and security groups. So they will deny all the traffic going to particular subnets, for example. And that simulates that you've lost an availability zone. And there's lots more of them. The documentation in AWS is, as we know, generally pretty good with these kind of things. So there's a long list. You can even test FIS itself. So you can cause errors in your own experiment templates if you wanted. So it kind of is getting a little bit meta at that point, but it's good that they put that in there. As I mentioned, we've got the actions, the things that we're going to do to the targets. I talked about those: stopping servers, rebooting them. EC2s, you can do this wonderful thing where if you're requesting particular types of servers, an M4 X-large or something like that, you can say there's no capacity in this region anymore. So you can do all of those kinds of tests around your auto-scaling, how you handle those problems as they come through. Next step is, like most things AWS use, we can use IAM to control that. So every template that we create will have an IAM role associated with it. That describes what that template is allowed to do. And that is permissions, so go and tell me what Lambda functions I have running at the moment, look at things with particular tags, all of those kind of things. Plus permissions to actually run the experiments themselves. So we can use that, and that's really good, especially, let's say, I work in regulated industries. It's a joy. We have change control boards. We have to take the changes to them. We have to demonstrate what it is that they're going to do. They like IAM because they can look at it and they can see what it's going to do. It's defined. It's got a blast radius, if you like. It can't do things outside that. The other way that we can use IAM, though, is we can use it to control who can run FIS. So some of the people, the clients that I'm working with, they will give one set of users a particular role, and that will let them actually write the tests. They can put the templates together, decide what they're going to do. Another role can only take those and run them. And there's a third role that can only pull out the documentation, the results of the tests. So you can break down quite nicely and quite granularly what people can do with FIS. And as I say, that gives people confidence. If you're wanting to bring FIS into your environment and into your systems, you can show, look, we can control what this is going to do. It isn't going to start affecting things that we don't expect it to until we're ready. Another control that we can put in place is alarms. So how many of you use CloudWatch monitoring, CloudWatch alarms? Yeah. So if we're monitoring services and things go wrong, we'll put that alarm there. It will tell us about it. We can actually tie that into the templates. So if we see things happening that we don't want to, we can stop the experiments running. It stops them running away, if you like. And it's great that we can do all these things, but we probably want to document afterwards what's actually happened. So we can store all of the outcomes of this in logs. Now, we can either do to S3 or CloudWatch log groups, the same way we use Lambdas. We can actually use both if you really kind of wanted to take a belts and braces approach. You can put both of those in there. And one of the pieces of functionality that they introduced at reInvent last year was that we can now do automated reports. So it will take those logs, it will put them into a predefined format. If you have CloudWatch dashboards, it will pull the metrics off those so you can see what happened to your services whilst the experiments were running. You can take that and, as I say, if you've got things like change review boards or teams that want to understand what's happening, you've got that documentation. I will give kind of a word of warning. If you're wanting to run these on your own, it's about $5 every report you generate. That's fine for an enterprise. I've seen, yeah, we work with clients who wouldn't even flinch with that. But it's just something to be aware of. And actually, while we're talking about costs, how much does it cost to run these experiments? It's fairly cheap. If I remember, it's about 10 cents per, I want to say minute, but I will double check. It's either minute or second for whilst your templates are running. So it's a reasonable cost. Yes, there are definitely some costs there, and if you have actions that run over half an hour or whatever, it will start to rack up, but it's relatively insignificant, especially compared to the cost of running servers, say, sometimes. But the costs are all in the AWS documentation, as always. The last thing that we have, which was again introduced at reInvent, is what they call a handbrake or a safety lever. Now, I mentioned we work with financial services. The people who work with gaming is probably the same thing. If you've got a big new release coming out, you don't necessarily want people running experiments on the day that you do your releases. Banks generally don't want people doing too much testing in the run-up to, say, Christmas or Black Friday sales. They want to know that there's control there. So what you can do with these handbrakes is it's literally a tick box in your account, and it says, don't run any experiments. So at an account level, you have control over whether these experiments can run or not. And as I say, again, especially in regulated industries, that gives people a lot of confidence when they start to use FIS. You can turn it off in all of the accounts except your development ones maybe, just until you understand how well it works. Okay, so that's what makes up a template. So let's go on, and I mentioned I was going to talk about how we test Lambdas with FIS, since this is new functionality. Well, relatively new, in terms of AWS anyway. I'm sure that many of you work with Lambdas, but we'll just do a quick refresher in terms of what a Lambda is and why it introduces some challenges when we want to test the environments. So a Lambda is a service that AWS provides that lets us basically run code without, I want to say, worrying about the servers. We still have some configuration there. We tell it how much memory we've got. We'll tell it what architecture we're running on. Are we on an Intel or an ARM? Those kind of things. But generally, we don't have to worry about the underlying infrastructure. We don't have to worry about an operating system to run our code. Amazon will take care of all of that. We don't have to patch it. So it's a lot simpler. But that introduces some problems. If we were running our code on a server, we could probably log on, change the environment, maybe put some configuration files in there that changes the environment for our testing. With Lambdas, we can't do that easily. There's no way to log into that running environment and make changes. What we have got with Lambdas are, you might have heard of Lambda layers. It lets us bring pre-packaged code to a Lambda, and it will run it in the environment that we defined. Now, people use this a lot for things like bringing monitoring to Lambdas. if you're working with Splunk or Datadog or one of the other monitoring systems, they will have agents that they want to run. So they will give you a layer that has these things inside them. And it's the same approach that Amazon decided to take with testing Lambdas with FIS. They build a wrapper around the environment where our code runs. And what that wrapper is going to do is it sits there, and when our Lambda is running, it talks out to FIS and it says, are you running any experiments at the minute that could affect me? If we are, FIS will write some config into an S3 bucket that we need to provide. That tells it what actions we want to do, how long the experiment's running, all of those kind of things. And then that Lambda layer picks that configuration up and uses it to modify the environment where our code runs. So we don't have to make any changes to our code for this other than putting the layer around it. I mean, we've all probably been in code situations where we do if debugs, this kind of thing. But that means that we're introducing changes to the code just for our testing. This takes it away. This all sits outside our code. It's just a wrapper around it. So, as I mentioned, this is set up with the wrapper. We do have to set 2 environment variables as well. I won't go too deeply into these, they are in the documentation, but we have to tell it where that S3 bucket is that FIS will put its configuration, and the wrapper will pass information back to FIS. And the other one is we have to tell it the path of where the executables for the wrapper is. And it's literally, it's something like /ops/exec/wrapper, something like that. You'll see the name as I go through the demo shortly. Okay, so that's how we run the tests against Lambdas. We use this wrapper around it, we set those environment variables. There are 3 actions at the moment we can carry out with Lambdas. We can add a delay. So if we're writing microservices maybe, if we've got APIs there, you can introduce latency, you can slow them down. Lambdas have maximum runtime, I think it's 15 minutes. You can actually extend that delay past the 15 minutes, so you can cause your Lambda to time out. So that's a really good test of your monitoring. Can you tell if a Lambda's failed because it's timed out? We can modify the responses that we get back from the Lambdas. Now, if any of you have worked with APIs, we normally work with HTTP response codes. So the typical one we want to see is 200, an OK code, everything worked. But sometimes we'll see other ones, 503s, 404s, if files are missing or something like that. We can change what our Lambdas will return without changing the underlying code. We'll do it through the experiment templates. And that's what I'll actually demonstrate today. We can also mark failed. This is what AWS call it. I'm not sure it's the best description. We can introduce errors into our Lambdas. So it will generate stack traces, things like that. So again, we can make sure that our observability is there. Does our code handle errors properly? Are we doing error catching? That kind of thing. Okay, and with all of those 3, I suppose if you cause the timeout, you can't do this. You can either let the Lambda still run to completion, so you can modify the response code but let it run, so if it's doing some processing, that will still take place. And the same with an error. It can introduce an error, but the Lambda will run to completion. Or you can actually stop it at the point the action runs, so you can simulate that the actual Lambda has failed. You've got that control over it, and we'll show you that in the demo. Okay, so time for the demo. I will say this is pre-recorded because I do this demo at conferences and things like that, and Wi-Fi is notoriously patchy at those kind of things. That doesn't mean that there aren't a few errors in there, but you'll see those. That's my video editing skills. The QR code is a GitHub repository. So this contains a CloudFormation template, infrastructure as code, and a Lambda that it will deploy as well, along with an experiment template. Now, I'm going to show you how to set up the experiment template, but if you want to take that, clone it, you can deploy it into your own environments and test it out as well. Okay, let me just grab a quick drink before we do the demo. Now, I am going to do most of this through the console. Now, obviously, normally we'd be looking to invoke this through a pipeline or something like that, but it's easy to show you through the console. So, we will start. So, what I have done is the code deploys some lambdas into your account. You'll see one of them is configured with FIS. It also deploys it without FIS. The one with FIS will have some configuration set. Down at the bottom, it's got that lambda layer I talked about. So this is provided by Amazon, and you can pick that up. There's an ARN for it in the documentation. We just put that in place and we choose what architecture we want. We've got the configuration that we need to put in place. I mentioned the two environment variables. So the configuration location that tells you the S3 bucket we're going to use to pass information backwards and forwards, and that exec wrapper. Okay, I got the name. Absolutely, I got ob to write. That's fairly good. The other thing I'm doing is I'm putting a tag onto this lambda. I'm just going to put FIS demo with a value of true, and you'll see why in a minute. We don't need that for the wrapper to run, but it's going to be useful. Okay, I will apologize for the Python. As I say, I'm an infrastructure guy, I'm not a developer. But what it basically does, you can see line 15, there's kind of a hello world message. Line 20, it's just going to list the buckets in the account. Just really simple stuff. It just outputs that list. So if I run that, it's going to have a cold start, so it takes a couple of seconds, but tells us the lambda has succeeded. It returns that status code 200 we were talking about, tells us everything is okay. And because we're running this in the console, we can see the logs as well. Now that red text there is coming from the FIS wrapper. So we can see that it's properly configured, it's running properly. It will warn you if you get the configuration wrong. And no active faults. There are no templates running at the moment. So it carries on and it just lists the bucket. I've just blurred out the account IDs on there. So a really, really simple lambda. Now, when we run the experiments, we're not going to change that code at all. What we're going to do is we're going to come into FIS in the console, and we're going to create an experiment template. So we're going to go through those steps. It's always a good idea to put a description and a name in, because we might have several, dozens, many of these. This makes it easier to understand. As I said, I'm going to take the action that modifies the response code. You can also see down at the bottom there, we can choose whether we're just targeting resources in this account, or we can actually target resources across multiple accounts. So that gives us a lot of flexibility in how we test things. Sometimes your databases might be in one account, your application's in another. So we'll come in, remember I talked about actions and targets. We start by choosing an action. Again, we'll pop a name and a description in. It just makes it easier when we come back to look at these to understand what we're doing. Okay, modify the lambda response code, try and be descriptive. If we drop into here, we can see all of the target types we can choose. You can see there EC2s, ECS, FIS, networks. Not surprisingly, we're going to choose lambdas. And when we choose lambda, it will let us choose then from the particular actions. And it gives us those three things that I mentioned. We're going to choose changing the response, and you'll get different parameters depending on which action you choose. It's asking me to choose what kind of response I'm returning. I'm just telling in here, in a moment. I'm just going to tell it to return JSON, typical approach to returning data. I'm going to tell it how long this action is going to run for in the template. I'm going to say 5 minutes, you can choose seconds, whatever you want. And we can also choose how many of the targets are we actually going to affect. We could choose 10% of the targets, we could choose 50%. I'm just going to keep it simple, choose 100. I mentioned we can choose whether the lambda fails or not. I'm turning that off. I don't want to prevent the execution. I want it to let it run through. And the status code I'm going to return is 418. We'll see if anybody knows what that one is later. Okay, so I've described the action that I'm going to do. I'll save that. Yeah, as I said, some errors in here. The name, it doesn't like spaces, so you've got to put dashes in there. So we'll save that. And it puts a placeholder in for the targets. We know we're looking at Lambda functions. So it lets us choose how we define those. We could just go and say, show me all of the resources that we've got, and we could choose from the Lambdas that we have in place. That works, it's fine. But probably a better approach is to use things like filters and tags, hence why I put a tag on the Lambda earlier. In this case, I'm going to say, look for Lambdas that have that tag FIS demo. You can just look for the tag, or you can look for specific values. I'm going to set that to true. So we'll save that. It gives us a little summary. And you can see we can put more actions and targets in there, so we can start to build fairly complex templates. We can choose whether the actions run in parallel or in serial, so we can build lots of multiple approaches. I mentioned we have to tell it the IAM role. When you look in the code, you'll see that it predefines a role that it's going to use. That just gives it things like list the Lambdas, run this experiment. Come to the next screen. This is, you'll see the top stop conditions. Do we want to use an alarm to stop our experiment? In this case, I'm not going to do that. You'll see report configuration there, this new optional approach. And then the logs. I'm going to tell this just kind of belt and braces, as I say. You can choose to send it to an S3 bucket. You can also give it a prefix if you're using an S3 bucket. That means you can use a single bucket, but the different experiments will go into different folders. Well, it's S3, they're not really folders, but we'll pretend. And we can do the same with the log groups as well. So I'm just setting this up. It would be a good idea to put some tags on there, because if somebody's doing some reporting later. Going to the next step, it gives us a summary screen. So we can use this to check to make sure we've actually put everything in place that we want. So we can see the actions that we're going to carry out, the things that we've targeted. We can see the roles that we put in place, the logging, etc. It's just that summary screen, just to confirm. You can go back and edit things if you need to. Okay, but we'll come down to the bottom, we'll click create. Because we're doing things that potentially are going to impact our environment, it tends to ask us to do a lot of confirmation as we go through. So I'll click the create. And this is what you see once you've defined a template, or if you open up an existing one. There's a summary of what it's doing. You can see the actions, how long it's going to run for. You can see the targets, so the things that we've defined. So we've got that placeholder, the function targets. If you scrolled over, you'd see that we're filtering on tags. And if we do the preview, it will actually look in your account and say what kind of things are likely to be impacted by this. It's not guaranteed that that's going to be the ones that are, but it gives you an idea of the things that it's likely to pick up. We can come up, we can see the timeline of how the experiment's going to run. If you've got multiple actions, it will show you which things will be running at which point. In this case, it's just a simple one. You can also set schedules, so you can tell it to run this every Monday morning at 9 o'clock, that kind of thing. Okay, but let's come in and we're going to start that experiment that we've defined. So again, it will ask us to confirm that. Tells us it started it. You'll notice that that state is initiating, so it's getting everything ready. It's making sure there's a Lambda layer it can talk to, and it's running now. So let's jump back to that Lambda. We're not making any changes to the code, we're just going to invoke that same Lambda. So we'll come down and we'll just trigger that. And what we'll see is, again, there's that little bit of a delay. It tells us it's succeeded, it's run all of the way through, but it's a different response code. It's changed from that HTTP 200 to a 418. But remember, we haven't changed any code. We're not introducing changes. We can see that this time it found an active fault, an active experiment running. And if we scroll down, ignore the shutdown. If we scroll down to the bottom, it's actually telling us what that action is doing. So again, this all goes into the logs. We can pull this out later for documentation purposes. Okay, so that was a demo. It's obviously a really simple one, but hopefully you can kind of get a feel for the things that you can do with Lambdas. And the other services work in very similar ways. You define the actions, introducing packet loss. You can fill up the memory on an EC2 instance or a container, Kubernetes pods. You can interact with those. You can do those kind of things as well. It is really useful, especially as you start to get into it. As I say, we've got a lot of teams that are just starting out. They tend to do things like, we want to do resilience testing. We'll stop an availability zone. That's one that we tend to see people using a lot to start with. They want to know that their load balancers and their auto scaling is going to work in real life. Okay, so you'll be pleased to hear we're nearly at the end. But I want to give you some things to take away and think about if you're thinking about using FIS or approaches to testing our infrastructure. How many, right, I'm not going to tell you the quote. Who's seen the reInvent keynotes on the Thursday morning by Dr. Vogel? Anybody? Okay, I can bring it out then. So the phrase that they nearly always use every year is everything fails eventually. And it does, things go wrong. Everybody quotes that when they're talking about resilience. What they don't talk about is the next bit. You know it's going to fail, so plan for failure. Think about the architecture that you're building. How can you build resilience into that? And also into your applications. How can you have your applications recover if an error comes in? Shared responsibility model. We normally use this when we're talking about security with Amazon. They'll talk about how their data centers are secure. You can't just turn up at the door and go in. There are physical checks on who can go in there. They will take care of the power and the air conditioning and the network connections, all of that kind of thing. But I would also say it applies to our testing and our testing approaches. AWS give us a lot of features that bring resilience and redundancy. I mentioned auto-scaling, load balancers, all of those kind of things. It isn't 100% panacea. You can put the best, most resilient infrastructure in the world in place. And there are still going to be times that you will see errors. I was working with a client at the bank where I'm working at the moment, and they were doing this. I talked about turning off availability zones, and they were going, look, we've got auto scaling groups, it will just switch over. We've always got plenty of availability in servers in all of our subnets. We've got load balancers. So when they went away and started running experiments, they were quite surprised that occasionally they saw errors. Now, if you think about it, that's actually not that surprising. If you've come through the load balancer and you're talking to an EC2 or a Kubernetes server, and it goes down, you've lost that connection. You can't get that response back. You will get a notification somehow that it has failed. Most of the time, the next person to come along will just say, okay, it's dead, it's failed its health checks, and the next people will get a good experience. But you will still see a few errors, and people forget about that. And as I say, that's where we need to think about how we do that planning for failure. We need to, don't just assume AWS will take care of everything with the resilience. We need to do some work as well. And we need to think about how we're going to recover from failures. Who'd heard about the Google failure earlier? Was it earlier in the week, last week? It was a couple of days ago. Yeah? Yeah. Yeah. So it was Google's IAM model, how they handled security, introduced some failures, and a lot of people use Google Cloud, so anything that was using that got failures. That was fine, they worked that bit out fairly quickly. The problem was, as they kept bringing servers, trying to bring it back up online, everything that was relying on it went, the service is back. And it just threw loads of requests at it. And the servers would crash again, because there was just too much incoming traffic. We want to avoid that, so think about if parts of your service have failed, about how you can bring them back in gracefully. So things like back-offs, if you're talking to a service and it doesn't respond, don't just keep hammering it. Introduce delays in when you talk to it. Don't just do it every second. Introduce some randomness in that, so maybe every second and a half. Because if everybody hits it at the second, you're just going to see the service go down as it fails, or it takes longer to come back up. So as I say, think about how you can architect your code to recover from failures. That graceful degradation I talked about. Which bits do you need to bring back up quickly? Which bits can take a little while? As I mentioned, back to Jesse Robbins when he took this to Amazon, don't just use it as an opportunity to test your systems and the infrastructure. Use it as an opportunity to test your people. So think about somebody who's maybe new to your ops team. They don't know how the alarms work. They don't know what it looks like if you have failures in your application. You can use this template to show it in a repeatable way. You can work, how do my runbooks work when we've got errors? How do I track what's gone wrong? How do I investigate? Where do I look? And you can also manage your incident management responses. When do you escalate it? So it isn't just the tech, it's the people and the processes that you have in place as well. And one final piece, and this kind of gets people when they start to look at FIS. FIS, we can tell it about the infrastructure that's there, because that's what it's designed to do, to test our infrastructure. What it doesn't know is our applications. It doesn't know how to test them. We are the experts on those. So FIS will introduce the conditions that we want to test, but we have to think about how we then test those applications. So we're going to use Postman for API, things like that, Selenium for web testing, all of those kind of things. So just be aware, FIS manages the environment. We still have to run our tests on top of that. Okay, we'll skip that one because you don't need to do that QR code. This is it, Q&A time. I don't know if anybody has any questions.
So successfully avoided a problem that we have in the future by doing this. Do you have like real examples where this actually worked, that exercise? From your own work?
So from ours, yes. I mentioned that setup where they were testing the multiple availability zones. So the team were doing their testing, they were getting those errors, and that was one thing that they did, is the applications that were depending on those services, they built degradation into there. So it didn't just give them the error, it said, this service isn't available now, come. We've all seen the message, please retry in a few minutes or whatever. So they introduced something like that. We mentioned that thing about capacity errors. You're asking for a particular type of server. So we've seen teams that had just, I want 10 M5X larges or whatever. Build some resilience in there. Can you use an older approach? I think Amazon call this fleet management, where you choose different, I want so many of this instance type, so many of this instance type. And you can use that, yes, you can use it to manage your costs, but it also brings resilience. If some of a particular instance type aren't available, you've still got enough capacity to run your load. So yeah, people are using it, and yeah, it works well. I will be honest, none of our teams are using this in prod yet. So it's that approach we want to take. When you bring it into a new client, it's get the confidence, show them those controls that are built in, start them with simple scenarios so they can see how it works, get that confidence built up, start to build that library of templates that they can use, and hopefully as they get more confidence they can go on and use those. Hopefully that answered the question. Yeah.
So I have a small question. So when it comes to most of the most up-to-date topic in tech world is AI, right?
Mm-hmm.
So when it comes to applications with LLMs, neural networks, most of the time the output is unpredictable.
Yes.
So how would you take an approach to chaos engineer this kind of applications, because the output is always unpredictable?
Yeah, so first of all, we can't do anything with AI at the moment. There's no actions around Bedrock, for example. That's obviously the big service that people tend to move towards as they start with AI. What I have seen people doing, not with chaos engineering, is that they will run their systems against multiple models. So they're looking for some kind of consistency. Is one giving you wildly different answers? Does it just fail? We've seen people doing security testing with this, for example, with AIs. Are you an AI agent? Tell me what kind of model you're running this kind of approach. Most of the models will say, no, my name's Fred, or whatever. So we can't do very much with chaos engineering directly with AI yet, but the models, the LLMs, are not the only parts of our system. We often have lambdas that are feeding data into RAGs, for example, the vector databases, our internal knowledge stores. You can affect those. So you can, what happens if we introduce an error? What happens if we really slow them down? So half of our lambdas that are feeding in fail. So yeah, we can't do AI yet. Who knows? Reinvent's not that far away. Maybe they'll announce things. Yeah.
I want to appreciate you for a wonderful talk.
Thank you.
Yeah. So my question is, with AWS's separation of duties, what do you call them?
The roles?
Not roles. Customer responsibility.
Oh, the shared responsibility model. Yes. Yeah.
I know where AWS's responsibility is, and that's for the client. So, does AWS allow you as a client or a user test their systems, especially when you mentioned using Chaos Gorilla to shut down the
Yeah, because you're only going to be shutting things down in your own accounts. It doesn't affect everybody else's accounts. You remember when we set the templates, are we doing it in this account or do we want to use multiples? I think if I remember, when you use multiples, you can say which accounts, you can tie it down to specific ones. You can also use other controls within AWS. So most of the clients that we work with have organizations. So they're going to be using things like SCPs. They put controls over the entire organization. You can only do this to resources in these accounts, or if you have these tags. So anything that we can do with FIS is just constrained to our own accounts. So yeah, they'll kind of let you go wild.
Having multiple accounts, right? Let's say additional has about 10, 20 accounts.
Yeah.
And how does it integrate with the Chaos Gorilla too?
So it doesn't use Chaos Gorilla for those. It will use FIS in those accounts, and the role that's running when you define the template will typically need permissions to access the resources in those other accounts. So you need to be able to say, show me all the EC2 instances in my server account, show me the RDSs in my database, or more typically in my dev, test, or production accounts. So again, we use IAM to control what it can do. We have to tell it, you have permission to do this.
So does AWS allow me to use external tools now, apart from that Chaos Gorilla animation? Can I use external tools now to test my accounts?
If they're in your accounts, I would say generally yes. There are some things you have to be careful about. If you are doing things like penetration testing, for example, they get slightly twitchy if you're doing things like denial of service attacks. Because it's harder to control that. I don't know if they are. It used to be a while back, I've not looked at this recently, if you wanted to do, for example, port scanning across your accounts, so you could see what ports were open, you had to ask permission from AWS. You had to fill in a form and say, I'm going to be doing this in this account across these network ranges, because there was a chance that they would see that as a real attack.
I think that actually is better.
Yeah.
You can do that.
You can do it. I'm not saying it's a good idea, at least without telling Amazon first. But with FIS, because it's constrained, you've got to have the right permissions. You've got to give it the permissions to the accounts. You can't really. It's a two-way thing. I don't know how many of you do cross-account work. You've got to have your source account. You've got to say, I will let you look at these accounts. In the destination account, you've got to say, I will let that account that's coming in do these things as well. So you've got to have both sides matching up. So it doesn't matter if I try and do things to the resources through FIS. If this account doesn't let me do that, I'll just get blocked. Okay. I don't know if there's anything else. I put the LinkedIn up. I'm going backwards now. That's the QR code for my LinkedIn profile, as I say. So feel free to reach out. I think my name's on the meetup anyway, so you'll find me on there. Quite happy to take questions, conversations later. I have been asked to let people know, I know most of you working already, but GlobalLogic has got some positions open across the UK. We do have still some remote positions for things like data architects, etc. If you looked at that QR code, if you were particularly interested, if you see any role that's got hybrid, even if it says London, don't feel you can't apply. The nearest office to here would be Edinburgh. So that's it. I've done my marketing speech.